In this video, we will look at how to set up instance-level network security on an Oracle Linux instance on Oracle Cloud Infrastructure. Instance-level network security is ensured with the instance firewall in conjunction with the Oracle Cloud Infrastructure VCN, or Virtual Cloud Network, security list. Security lists are customizable and each network can be more or less restricted depending on the needs and scope of the network. Changes in security list rules may cause connection problems which might not show up in instance log files. So you'll have to make sure you consider the security list if you're troubleshooting connection problems. If the instance administrator is not the same person who manages the VCN security list, then coordination is required between the various administrators to enable connections. In this video, we will use the example of enabling HTTP communication between client and server instances built on Oracle Cloud Infrastructure. We are currently looking at the terminal windows to these two instances. In the left terminal, we have set up an SSH connection to a Linux client looking to access a HTTP server. In the right terminal, an SSH session to the HTTP server. For convenience, the client and server are both connected to the same private subnet of our VCN. On the client, using curl, the server's IP address, and port 80, we run the command curl-v http://10.0.0.4:80/index.html to request the index.html file on the HTTP server. After a few minutes, the request fails because the connection times out. The timeout occurs because there is no rule in the VCN security list that allows for ingress network traffic on port 80 for any instances using the VCN. Switching to our Cloud Web Console, let's look at the current security list for the VCN. Using the menu, Networking, and Virtual Cloud Networks, we navigate to our VCN list. The VCN we're working with is VCN-10. Clicking on its name, we see its details. Under Resources, Subnets is selected, so we are shown the two subnets provisioned for this VCN. There is a default security list created for a VCN, but separate security lists can be created for individual subnets to control traffic just for the VNICs attached to the subnet. We will work with the default security list for the VCN, so we can get to it by selecting any subnet in the list here. We select the name of the subnet that our HTTP server is connected to, in our case, VCN-10-01. We see the default security list for the VCN present, and if we wanted a security list just for this subnet, we could click the Add Security List button to create a new one. For this demonstration, we click on the default security list name, and scrolling down, we are shown all the rules being implemented in this security list. Be aware, there might be multiple pages of rules in this list. Our client instance failed to get the index file using HTTP because there is no rule for this in the subnet allowing ingress traffic for port 80. To add the rule for this to the security list, we click on the Add Ingress Rules button. For this demonstration, we are only interested in serving instances on the same VCN, so we input the VCN CIDR block range 10.0.0.0/16. To control ingress HTTP traffic, we leave the protocol as TCP and enter 80 for the destination port. If we wanted to create multiple rules in the same dialog, we can click another ingress rule to add more, but for us, this one is enough. We click Add Ingress Rules. Any new rule gets added to the bottom of the list, so to see our new rule, we scroll down and click to view the second page of the rules list. We can see the new rule created. You can find out more information about security lists at this documentation page. We return to the client and server terminals. On the client, we run the command curl-v http://10.0.0.4:80/index.html again. This time the security list rule allowed the attempted connection to the server, but the connection failed with a different failure message stating no route to host. To fix this, we have to work with firewalld on the server instance. The firewall daemon on Linux is a dynamic firewall manager. For firewalld on a Linux instance, you can create different network zones. In this demonstration, we will work with the default public zone. Changes to the configuration can have immediate effect, but are not persistent. However, we can make configuration changes permanent so they persist over a reboot. To work with firewalld, we change the privilege mode by running the command sudo bash. To see the default public zone settings, we run the command firewall-cmd-info-zone = public. The firewalld service uses a combination of standard ports, protocols, and/or addresses. We see the current supported services configured for this zone, SSH, and DHCP v6-client, but HTTP is not included in the list. The HTTP service specifies TCP protocol and destination port 80. This service, along with others, is defined in the /usr/lib/firewalld/services directory of the instance. So, on our HTTP server instance, we modify the firewalld configuration to allow HTTP by allowing the TCP protocol on port 80. We run the command firewall-cmd-add-service HTTP. Without a specific zone included in the command, the change is made to the public zone. We run the command firewall-cmd-info-zone equals public to display the public zone information again. This time the list of configured services includes HTTP. You can find more detailed information on working with firewalld by looking for this video, which is also available. Returning to our client terminal, we run the command curl-v http://10.0.0.4:80/index.html again. This time the command succeeds. In the response, we see the HTTP server IP address, the HTTP status 200, and the content of the index.html file. The client connection to the server is now working after modifying the security list of the VCN and the server instance firewall. Oracle provides an extensive number of resources which you can use to learn about this subject and others. Use the links here to find more content about this video, as well as Oracle Linux and using Linux and Oracle Cloud Infrastructure. That's the end of the video. Thanks for watching.